Hey there, in this video we are introducing how to pass data by value into a function in C++. And this covers sections 6.4 to 6.6 in the Gaddis textbook. So passing data into a function, if you think about a math function, like if you write f of 2, f parentheses 2, the 2 is the data being entered into that function to work on. So we want to do the same kind of thing in our C++ code. Why is that even important? Okay, so the important thing, the reason why you need this is that by default, you have no data access to other functions in your program. By default, functions cannot access any variables defined in other functions. So we use the word scope for that. We've talked about that before. Remember, variables only have scope in the one function where they're actually defined. You cannot access that variable from any other function. So this means, so to begin with, this feels like a restriction, right? The first time you run into this feels like a restriction. Why am I being locked out of accessing all the variables and all the other functions? But this is a good thing. This is one of these good focusing elements in a structured programming language like C or C++ or Java. They all work this way. The alternative would be if I'm working on a really super large program, it's thousands of lines long, and there's hundreds and hundreds of variables, I would have to memorize all of the hundreds of variables and think about how they all interact and think about all the different variables that I have access to or could possibly change right now. So by restricting that, we're going to have a very small list of variables that are accessible to our function passed in by the parentheses, right? And so this means that a programmer only needs to focus on the variables in one function at a time instead of memorizing the whole program. Okay, so anybody ought to be able to keep track of like the 3 or 4 variables, the 3 or 4 pieces of data that are being passed into this particular function, and that is the only stuff in the entire universe that you have access to while you're working in that function. So it's very much going to mentally focus on us on just a couple things that we have to deal with. Now, that having been said, any data that a function needs for processing is going to have to be explicitly given in the parameter list, in those parentheses, to allow it to have access to it. So that's the key thing. If you don't put anything in the parentheses, your function doesn't have access to any variables at all except for the stuff that you declare in that one function. Okay, so how do you do that? You're going to modify the signature to your function every place it occurs. Remember, there's going to be 3 places at least where that occurs. So in the function prototype, right, you're going to have the return value, and again, we're going to talk about that mostly later, the name to your function, and then you just put down the types of data that come in. So maybe my function needs an int, comma, and then a float, right? And there can be more than that. Separate those by commas. If I have a function that just works on one single parameter, I can just say f of int or whatever. So just the types. Now, optionally, you could give names to those variables, kind of like you're declaring variables, but they're optional. So a lot of us leave them out of the function prototype to make it shorter. But when you see the function header, when you actually define the function with what it does, you're going to have to add both the types and the identifiers, the good names for your parameter variables in the parentheses. So here, return type, name of my function, I might have int number of at-bats, perhaps, and then float batting average, possibly, if that's my function is doing something in baseball. So the function header's got to have both the types and a good identifier, a good name for the variables there, so that it can actually do something with it when it refers to them in the statements of the function. And then when you actually call it, again, you don't need the return type because at this point the compiler has seen the prototype, it knows that already. You just name the function. And again, you don't need to put the types in the parentheses because at this point the compiler already knows that too. So here you just put down values separated by commas. So you could put down a variable here. You could actually put down a number like 5 and then comma, 0.08 or something like that. And that's the data that's actually being sent into the function at that time. So prototypes just have types usually. The header's got both the type and the variable name, and then the function call just has the values. You don't specify the types again. So what does that actually do? When you put that all together, what does that actually do for you? So this technique of passing data in the most basic way is called passing by value. There's other stuff later on, but this is the basic way. So passing by value is a basic strategy for argument values to be copied into parameters. So you have the calling context, maybe the main function, right? You have the interior of the function, and the data you're sending from main or wherever is being copied into these new variables inside your function. They get copied in the parameters in the same order that the parameters are laid out in the definition. So I want to emphasize that these are different variables. The variables in the call are different than the internal variables for the parameters. And we try to be careful about the terminology about these things. Technically, the outside call are called the arguments, and the inside the function, they're called parameters. Again, they're really two different things. So arguments outside, parameters inside. I think some other people might call these actual parameters versus formal parameters. Like outside, it's actual parameters, and inside, it's formal parameters, I think. But anyway, it's the outside and the inside. Here's a little picture of that. So in a second, on the next slide, we're going to see a program that has this function called showSum. It takes in some data, adds up all the data, and prints it to the screen. That's it. It's called showSum. So here, there's going to be a function call in the main function, calling showSum and passing in these variables that you got from the user, value 1 and value 2 and value 3 separated by commas there. Okay? And so when that function call happens, you're going to be jumping into the function definition, which is down here, right? And the values that you put in the function called are being copied into these new variables that we're calling num1 and num2 and num3. And you see those basically being declared for the parameters in the function definition, like we said. Okay, and once those are there, then the function actually takes these num1, num2, num3 variables, adds them together, prints them to the screen. So the next question I usually ask my students is, for everything that's on screen here, how many variables are there? How many total variables are in view right this second on screen? And the answer is 6. In the main function, you've got value 1, value 2, value 3. Inside your showSum function, you've got num1, num2, num3, and those are all different variables. They're different locations in memory for storing information. Now, it just so happens that as the showSum function starts up, num1, num2, num3 contain the same numbers that value 1, value 2, value 3 do, but they are 6 different places in memory. And if in showSum I start modifying num1 or num2, right, it only modifies num1, num2, not the variables value 1, value 2, value 3 that are back in the main function. Okay, so I feel like that's an important thing to highlight at this point. Now we've got 6 different variables in our program. So here's that program we're thinking about. This is program 6.8, and this program demonstrates a function with 3 parameters. You can see the prototype at the start, which is what I would expect to see. Right? It's a void function, not returning anything, called showSum, takes 3 integer parameters. And you can see again the prototype, we're just putting down the types of things that need to come in. 3 integers. Here's our main function. You have this value 1, value 2, value 3 variables like we talked about. We prompt the user to enter 3 integers. Right? They type them in. There you go. Call the showSum function. Just like we said, pass in value 1, value 2, value 3. And that call jumps you into showSum. We knew that before. But in addition, it copies the numbers in value 1, 2, and 3 into these 3 new variables, num1, 2, and 3, and then you can work with it. And that's what this program's doing here. Okay, so here's program 6.8 in the IDE, and we can test and confirm what this does. Compiles fine. And here we are in the main function, right, prompting the user for 3 integers. So, it could be anything. I'll type in 10 and 20 and 50. And then the program calls that showSum function, and showSum says, hey, that's 80. Okay, so obviously that's working correctly. But let's step through that in the debugger and kind of keep an eye on exactly what variables exist. So put a breakpoint at the start of the main function. Debug this. There we go. So I want to put some watches here, and as I said on the lecture slide, there's actually 6 different variables running around in this program. So in the main function, there's value 1. Hopefully I spell all these things properly. Value 2. value 3, right? Hopefully, no surprise at this point, these variables all have random garbage, some kind of crazy number sitting there based on the random bits when the program starts up. But then there's also these parameter variables down in the show sum function. There's num1, there's num2, and there's num3. Now you notice in my debug window here, for those variables, those are showing up in red right now saying not found in current context. So the thing is, if you don't, before you get into that function, those variables don't exist. They're not accessible and they literally actually just don't exist in the system. Local variables or parameter variables are only actually created in memory when you get into the function. So the first three there, they're clearly different. The first three, at least they exist and they're currently holding random garbage. And the other three here don't even exist yet. There's no place in memory for them. So let's start stepping through this and see how things change. So I'll do that prompt statement there. Right, enter 3 integers, I will display their sum. Here comes the sin statement. Hopefully this will let me type over here now. Yeah, 10, 20, 50. And you'll see the 10, 20, 50 go into value 1, 2, and 3, right, in order of the extraction symbol. So just hit enter here. Great. So now value 1, 2, 3 have that 10, 20, 50 that I entered as the user. Now we're about to jump into the show sum function. Again, num1, num2 don't exist yet. As we jump into the function, right, do you know what line we're going to go to? Hopefully you do. I'm going to click into function for that and see what happens. So we're going to jump into the function, and as we do that, we're going to copy value 1, 2, and 3, because those are the function arguments, into these variables as they get created in memory for the first time. Bam. Okay, so now num1 is holding 10, num2 is holding 20, num3 is holding 50. So whatever order I put them down here, right, that's exactly the order they're being copied into these variables here. But the thing I want to emphasize is there's 6 different variables here. Right. At the moment, see, again, the debugger's being a little bit flaky here, but you notice at the moment it's saying that, value 1, now I don't know what that is, because that's back in the main function. So we should talk more about that. But anyway, here you are in show sum, and now you have access to num1, num2, num3. Going to add them all together, going to print them to the screen. Right, there's the 80 that just showed up. You come out of this function. You're going to go back to where you called it, right after you called it. So I think it's going to go back to line 19 as this function ends. There I am on line 19. And then the program is ending. Great. Okay, so definitely 6 different variables. They weren't all the same thing all the time. And if I wanted to, I could have changed num1, num2, num3 down here, and it would have changed those. You can see they don't exist anymore. And the debugger just figured that out actually. So, so hopefully that's clear on exactly what we mean by passing by value, copying these numbers in to new variables down here. And as the program wraps up, all this data is being recycled, all those memory locations are getting scrubbed out, and the program's over. Great. Okay, another example. Okay, so trying to dig into these details about exactly how function parameter works. This program demonstrates that changes to a function parameter have no effect on the original argument. And this should make sense because they're different variables, which we've been emphasizing kind of heavily, right? So this program, and it goes for 2 slides here, a little bit longer. We knew that was going to happen. There's a function prototype to a function called changeMe. Return type is void, which is what we're doing for all our functions right now. Takes in one single integer, right, called changeMe. So main function here has a variable called number. It's initialized to 12. Line 14 is going to print out the number is 12, obviously. Then it calls this changeMe function, right? ChangeMe passes in the 12, really, a variable holding 12. And then afterwards, it's going to display, now I'm back in main again, and the value of number is something. Okay, maybe we can figure out what that is. I'm going to go to the next slide, see what the changeMe function actually does. Right, here's the definition of the changeMe function. You've got this integer parameter that we're calling my value as long as you're in the changeMe function. You take my value, you change it to 0, you print out now the value is 0, obviously. And then when this changeMe function gets done, of course, it's going to jump back into the main function. I'll go back here. Right, it's going to jump back to line 21, and then it's going to print, now back in main again, the value of number is, what do you think it's going to print at that point? Do you think it's going to print the 12 that number was initially, or do you think it's going to print the 0 that my value became? You saw that, I mean, you saw it on the slide if you saw it go by really quickly, but we should probably test that. So here's program 6.9 in the IDE, and we can test what this does. Compile this, great. So remember, the question before us is, if Alice is working in the main function and she makes number 12, and then she calls change me and passes the 12 in, right? Then Bob's function changes that parameter to 0. When you get back into the main function, what is going to be printed here after change me? Is it going to print that number is 0, or is it printed it's 12? So it printed it's 12, right? If you followed what we were saying, that's pretty easy to predict. So the point here is that these two variables are different, right? We've got two different variables. We have number in main, which is its own thing. We have my value down in the supplemental function change me, but they are two different things. So the changes that Bob made to his variable do not have any effect on number back in the main function. Again, a good thing, because again, Alice can do her work confidently, knowing that her variables cannot be changed by accident, right? And Bob can do whatever he wants down here, and it's not going to mess up somebody else's work. Let's just run that in debugger just to make absolutely sure we know what's going on there. I'll put a breakpoint at the beginning of the main function where a C++ program starts. I can debug this now. And again, two different variables in this program. I'll put watches for both of them. There's a number that Alice has in her main function. And what is it down here? There's my value that Bob has in his change me function. And as we've seen before, as the program starts up, okay, number, at least it exists someplace in memory. It's got random garbage in it. The my value down in this function, that doesn't even exist yet until you jump into that function. It hasn't been created in memory yet. So let's go through this and see what happens. So first of all, number's going to get set from random garbage to 12. Great, got the 12 there. Obviously, we're going to print out the number is 12. Great. Going into this change me function. So as this happens, you know that we're going to jump into the change me function down to line 34. As that happens, we're going to be creating a new variable called my value, and we will copy the 12 into it, because that is what was put in parentheses. So I'll put into function here. Great. I'm in this function. Now my value had the 12 copied into it, but again, they are two different variables. So now Bob can do whatever he wants with this if he likes. He can set it to 0. My value became 0, but it had no effect on number because that's a different variable. And now obviously Bob can easily predict that this is going to print out now the value is 0. See that? And as we come out of this function, we're going to jump back right after where this was called on line 18. So we're going to jump back to line 21. Great. And at no point has Alice's number variable been changed, right? And we just saw, see, my value just got scrubbed out of memory. When you get out of a function, all the variables declared there just get recycled. So once again, my value actually doesn't exist anymore. And so now Alice's main function is wrapping up, and it prints now back in main again, and the number is 12. It's been 12 all along, right? At no point has number changed here. And that's good for Alice's peace of mind that if Bob has like a bad day, he can't screw up her work because there's no way he can change her variable. And that's that program. Now let me do one other thing to that, right? Kind of emphasize. So the first thing that we said in the lecture today was that by default, there is no data access to other functions. So let's just hypothetically say, and I can get rid of these watches now, hypothetically say that, I don't know, maybe Bob was having a sinister day and he wants to change number. He wants to screw up Alice, just as a joke maybe. So I'm going to come down into this change me function, and I'm going to add a line on line 36, and I'm going to say number equals 0. Okay, let's see what happens here. See, that won't compile. That's not permitted. You get this error here. It says number was not declared in this scope. Number is a thing that only exists in the main function. This is the scope for number. You cannot access it anywhere else. So even if, Bob either gets hazy, has a bad day, or tries to play a joke, that's simply not permitted. You cannot access data that's in another function, right? And likewise, same way around. If Alice tries to get at this my value variable, kind of same thing, my value equals 42, something like that, right? She tries to do that. That won't compile either. Exact same problem. My value was not declared in the scope. If I'm in the main function, I cannot access the variables in any other function. Works both ways, obviously. And again, that's a good thing because both programmers independently can be secure that as they're looking at their function, right, as Bob looks at his function here, literally the only variable in the entire world that he can access is just my value. He doesn't have to know about anything else. He doesn't have to memorize anything else. He doesn't have to worry about anybody else changing my value, because likewise, this is the only place in the entire code base that can possibly affect it. So that is providing our mental focus that while Bob's doing his job, he can literally forget about everything else in the world. Everything he needs to know about this function is on screen right in front of us right now in that highlight. That's it. And that's good, instead of having to memorize 100,000 lines of a program. Okay, so another detail that is important to be aware of, the difference between local and global variables. So local variables, everything we've done so far as variables have been that. Local variables are variables that are being defined inside a function, inside the curly braces to a function, maybe inside the main function, maybe inside the change me function, okay, or whatever function it is. Now, local variables that we've been using all along, and this is the normal thing that you do, are inaccessible from other functions. That's the main theme for this video, I feel. They are inaccessible from other functions. You can only use them. They only have scope in the function where they're declared, not anywhere else. Again, initially that feels like a restriction. But the advantage is that now other functions may reuse the same name. Okay, so if we didn't have that restriction and you had a large program with hundreds of variables, you wouldn't want multiple programmers tripping up over each other's feet. So you then have a possible problem where Alice uses the variable name number, right, to do some stuff, and Bob also uses the variable name number in his own function, and then as a result, he winds up overwriting Alice's data, which would be terrible because then Alice's function would all be bungled and not work properly, and vice versa. So by separating the scope out into multiple functions, Alice working in her function can have a variable called number, and Bob working in his function can have a variable called number, and that seems very natural to do, and they're totally separate variables. They have nothing to do with each other. They're different places in memory, and therefore Alice can do her work in perfect security, and Bob can do his work in perfect security and have no problem. I mean, I suppose the other alternative would be like have a master list. Here's all the variables we ever declared in our whole program, and it's hundreds of variables long, and Alice has rights to these variable names, and Bob has rights to these variable names, and Bob isn't allowed to use anything that Alice used, and if anybody makes a mistake, the whole program crashes. Right? That would just be kind of a nightmare to deal with. So much easier to limit the scope of the variables, and Alice can do whatever she wants in her function, and Bob can do whatever he wants with whatever variable names, and they're not going to step on each other's toes, and it's going to be perfectly fine. And just less to memorize. That's why we do that. The other thing about local variables is that they're destroyed when the function ends. When a function gets done and the program is finished with it, the program knows I don't need that memory space anymore, so it just gets recycled. It basically just gets scrubbed out of memory. It might sit there for a little while, but pretty soon some other variable is going to take its place in another function call, and that data will just be scrubbed away at that point. So keep in mind that local variables only have a lifespan while the function that they're in is running. And then they're gone, which is good because then you get to recycle the memory. So that's the normal thing, right? All the variables we've made so far are local variables, and that is what you should expect to do all the time. Now, admittedly, C and C++, these old school programming languages, have another option called global variables. You can define a variable outside a function, like before the main function even comes into existence. But that's trouble. I mean, historically, once upon a time, that seemed like you would want that, but that's actually trouble. Now, on the one hand, when you make a global variable like that, the global variable is now accessible to any function in the program from that point on. Accessible to any function in scope from where you've defined it on. All the functions, which again seems like a good thing initially. But then you have all these problems of Alice and Bob stepping on each other's toes. Now you've got to memorize that variable. Now you do have to come to an agreement about how you're going to use it. So we have found over time that trying to use global variables, forgetting the variables, making another variable of the same name, which then has a collision, which then masks, actually makes the global variable inaccessible all of a sudden, accidentally changing the global, so now Bob changes it and Alice didn't know about it. These are all really common, really super tricky errors. So nowadays, basically, nobody uses global variables anymore. Not for C++ programming. For Java programming, you can't even do it. It's actually just prohibited by the language entirely. So the general rule here is just avoid global data. It's permitted by the compiler, but you shouldn't use it. It's just a terrible idea. For what it's worth, that book, The Pragmatic Programmer, where we get the principle of don't repeat yourself, one of the tips in that book is also avoid global data. And we should definitely do that. That is the voice of experience. Now you can make globals that are constants. If you make a constant in the global part of your program, that does avoid all these problems because no one's going to change it. No one's going to accidentally trip over each other's feet. It's just going to be the same number all the time. That's okay. So in some of our examples and some of our labs, you will see us making global constants. That actually is acceptable and we can do that. But definitely don't make variables global outside functions. Make all your variables local. That's what everybody does nowadays. So here's an example that kind of thinks about that issue of Alice working in one function and Bob working in another function. So this program is going to show that variables defined in a function are hidden from other functions. I got a main function, obviously, and I've got another function called another function. Okay, and it's just void. It doesn't take any parameters or anything like that. So you notice that maybe Alice is writing the main function today, and Alice has picked a variable name called num, set it to 1, and is printing out in main, num is, well, obviously 1. And then calls another function, which is Bob's job. And you come back and prints back in main, num is. Now, what would Alice want, right? What would Alice expect for her work? Well, she set num to 1, she printed out num, and presumably Alice would assume that num is still 1. That's what she would want. Now, here's Bob's function down here, another function. Notice that he also declared a variable called num. It's a very natural, thing to use for a variable name. In his function, he's initializing num to 20. He wants it to hold 20, and he's printing in another function num is 20. So you have a num variable in the main function that Alice made. You have a num variable in another function that Bob made, and the important thing is these are totally different variables. They have nothing to do with each other. Alice doesn't know about what Bob did. Bob doesn't need to know about what Alice did. They don't have to have a conversation about who decided to use it, right? C++ keeps these things completely separate to local variables, completely separate functions, and therefore Alice can focus on her work and Bob can focus on his work, and all they have to look at is just the one function. Everything in the entire universe that Bob needs to know about his work is just in this function, and he can literally ignore everything else in this code file. And that's a good thing. Okay, and here is program 616 in the Dev C++ IDE. And again, the point here is we have two different functions. Again, maybe Alice working in main, maybe Bob working in another function. And they have both, coincidentally, decided to use a variable called num. And they're two different variables. Let's just make sure this works. Perfectly acceptable. That compiles no problem. And it runs no problem, right? It says in main, Alice's work, num is 1. In another function, num is 20. You're back in main, num is still 1. At no point did these have any interaction whatsoever. Now, that's fine. So realizing that you can reuse the same name in two different functions. They are two different things, and the two programmers do not have to coordinate. They don't have to have some kind of discussion about, like, I get to use the variable name num, you don't, which would be like a huge hassle all the time in a large program. So let me just run this through the debugger, and you know what? This actually starts to get a little tricky about, can I even put a watch on those two different variables? But I think I can do it, because I know a little bit of a trick in this debugger. So what I can do to distinguish these two variables with the exact same name is I can say, at least in this debugger, I can say one of my variables is in the main function, : called num. So that : here is called the scope resolution operator, and it specifies what part of the program I'm talking about. So there's the main function num, that's holding random garbage, and then there's the another function variable num. So I'd write another function scope resolution operator num. And you see, that's actually how the compiler, that's actually how the code itself handles the difference, distinguishes between them. So underneath the hood, as far as the compiler is concerned, the formal name of this variable is main num, and the formal name here is another function num. And currently, the main num at least exists with random garbage. And I'll step through this. So now that got a 1, and it can print out in main, num is, this 1 that you're looking at right there. And you jump into this another function. At that point, we're going to create this new variable down here. Okay, so another function num, now it at least exists in memory. Currently got garbage in it. Okay, now it's got a 20 in it. You can see these are two different places, right? There's the num in the main function, and there's the num in the another function, and those are two totally different things. So the one in main's holding 1, the one in another function's holding 20. Pretty clear how that's working, I hope. And down here in Bob's function, it's printing out another function. Num is 20. So anytime you refer to num here, you're talking about the num that's in this function. And as we come back, right, back in main num is, so when you see this, it's referring to the one that's in that function. And it prints out num is 1. Great. Okay, so hopefully that highlights that those really are two different things. Even if you're using the same variable in two different functions, that's great, because now we don't have to have big, long conversations about who's using what variable name. And your team will be a lot more efficient. Okay, so a couple other details here as we get familiar with properly using our functions. Each function should have a lead-in comment explaining what it does. And all of our examples in the book do that, right? They have kind of this fancy thing that's separated by asterisks. I would say if the function is short, like around 7 lines long, like we've recommended, then likely you probably don't need any comments at the body of the function, right? A comment is supposed to summarize a couple lines of code. And if your comment before the function describes what the function does, this function is going to compute the average of a series of test scores. That's all the reader needs to know. That's perfectly fine. So the 2 or 5 or 7 lines of code in the body of the function, maybe you don't need comments there anymore because it's just doing one job. And you can describe that one job in the comment right before the function. Right? So look at all the examples we've had and try to do the same thing. Now, I will say that the examples that we're looking at in the book, they have these very elaborate function comments set off with asterisks in kind of a fancy box. And I think I understand why they do that. Our labs do the same thing. So some workplaces use these elaborate comments, and they even go so far as to specify what each parameter is specifically. They specifically have like a line saying, here's what the return value is. Like you'll see that in our labs, as a matter of fact. And the reason why some places do that is that there are these automatic systems. Java has a system called JavaDoc. There's a system for C++ called Doxygen. And that software can read your code file, read those fancy comments, and produce a web page automatically, a web-based documentation for other programmers to be able to look up, Google search online, right? And that's a nice feature, honestly. So if you're interested in getting into that, you could look up JavaDoc, you could look up Doxygen, and kind of go in that direction. For our class, I'm not requiring that. I don't need the big fancy comment. I don't need you to sync up with Doxygen. You can maybe do that later in your career. But for my class, all I ask my students, just put one line. Just put / one line explaining what the function is that's coming up. That's perfectly fine. You want to do the big fancy thing, also perfectly acceptable. But please, for my assignments, please give me just at least one line comment explaining the function that's coming up, right? And then maybe that's all the comments you need. If your functions are short, about 7 lines, so someone can memorize it in their head in once, that's all you need. Just one comment before each function. Please do that. Okay, so that's a pretty good conversation about passing data into functions. And the important thing to realize is they are different variables. The variables you have in the main function are totally different than the variables you have in the supplemental functions. And you can even use the same name because they're totally different. And you can change the variables in the function and it will not have any effect on the original variables back in main or wherever the calling context is. So that's pretty important. Keeping things very safe for our multiple programmers to do their separate work and not have to coordinate and not have to mix up and bungle each other's variables. So that's why those scoping issues are set up to help support big teams working on big programs. So at this point, my students would get together for probably lab 6.2, introducing pass by value. Very short little program. This program just has a function that takes in, I think, an integer. And if the integer is a 1, it prints one old-timey proverb. And if the integer coming in is 2, it prints a different old-timey proverb. And that's good enough, right? So you want to try to practice as many of these, like making a function with incoming parameters as you can, because all programming looks like this. So the more comfortable you can get with this, the better. That's the story of data coming into your function. Now, the next video, we ought to do the reverse. We ought to talk about data coming out of your function. When the function gets done, passing back data back to the caller. That's called a return value, and that's equally important. So in the next video, we will be talking about return statements, about how you get data back out to the caller. That's pretty critical. So I hope I'll see you then for that.